Hello everyone, welcome to Basics e-learning.
In this video, I am going to discuss the basic signals that are used in signals and systems. This topic is very important and these basic signals are used throughout the subject. Let us discuss what do you mean by a basic signal. Basic signal or an elementary signal is the signal that occurs frequently in nature. So there are two types of these basic signals. They are continuous time signals and discrete time signals. So in my video, I am going to discuss these continuous time signals. They are unit step function, unit impulse function, ramp signal, exponential signals, sinusoidal signals, exponentially damped sinusoidal signal, and also pulse signal. The first one in continuous time signals is unit step function. Generally, unit step signal is represented with u of t. Why t? This is because of continuous time signal. So, if it is a discrete time signal, instead of t, we will write n. So, u of t represents the continuous unit step function. So, u of t is defined as u of t is equal to 1 for t greater than 0 and u of t is equal to 0 for t less than 0. Let us see the waveform here. So, the x-axis represents the time scale, y-axis represents u of t. So, u of t has an amplitude of 1 when t is greater than 0. So, this is t is equal to 0. So, when t is greater than 0, then you have an amplitude of 1. Whereas, for t less than 0, it has 0 amplitude. There is no amplitude here, right? So, this goes till infinity. So, u of t signal is discontinuous at t is equal to 0. So, where do we use this type of unit step function? Suppose say I have some signal that is extended from somewhere to somewhere. Suppose say it is extended on the time scale from -20 to -40. Right? So, this is some signal. Let us call this as x of t. Now, I want to extract a part of this signal. Suppose say I want only the signal from 5 to 10 seconds. Then in such type of cases, we'll be using this unit step signal. We'll define the unit step signal only in this time scale 5 to 10 and the rest will make the signal as 0. In such cases, we'll be using this unit step signal. That is, if you want to extract some part of the signal, we'll be using unit step signal. The other advantage is adding two or more unit step signals will form another new signal. So, to form a new signal, adding two or more unit step signals will help us. The second signal here is unit impulse function. Unit impulse function is represented with del of t. It is written like this, del of t, and it is defined as del of t is equal to 0 for t is not equal to 0. That means if t is equal to 0, del of t has some amplitude that we don't know. As I am talking about here unit impulse function, so we are taking this as unit 1 here. So del of t has amplitude only at t is equal to 0, that is equal to 1 when it is a unit impulse function. Then we will discuss the properties of impulse function here. So if you take a step signal here, any step function of amplitude 1 by delta and the time scale width as delta, then you take del of t is nothing but the derivative of your unit step function. So du of t divided by dt. So what is derivative? Derivative is nothing but area under the curve, right? So that is nothing but amplitude 1 by delta multiplied by delta, right? So that is nothing but here 1, which is nothing but your del of t, unit impulse function. So the properties of unit impulse function are it has 0 width, right? So this is just a single line that is extended at t is equal to 0 onto the y-axis. So there is no width for this unit impulse function. And then it has infinite height, right? As I said, only at t is equal to 0, it has some amplitude. That amplitude we don't know. As it is a unit impulse function, I am taking it as 1. And the third one is it has area is unit area and unit strength. So as the signal is extended only on y-axis, if you take the integration to find out the area, you will get only 1 here. Now I am going to discuss important properties of impulse function here. So first property is product property. So in product property, what happens to the signal phi of t if you multiply with del of t? As I said, impulse function is represented with del of t. So if you multiply this del of t with any of the signal, what is the resultant signal we'll see. Suppose say phi of t is the signal, some signal that is extended, right? So now I am going to multiply this signal with my unit impulse function, that is 1 here, or else some signal del of t, right? So then what happens? As the signal is 0 for t less than 0 and t greater than 0, this is 0 only. Everywhere else it is 0 except at t is equal to 0. So what happens here? Whatever it may be the amplitude of your signal here, less than t is equal to 0, as it gets multiplied with the amplitude 0 of your del of t, it will become 0. Suppose say the amplitude of phi of t at t is equal to 0 is some value, suppose say k, then k multiplied 1 by 1 is equal to k. So the resultant signal looks like this, because the whatever the amplitude that you have before t is 0 and t greater than 0 will become 0, because del of t is not existing for t less than 0 and also for t greater than 0. So if I multiply your base signal with del of t, what happens? The amplitude of the signal also will become 0 except at t is equal to 0, because at t is equal to 0 I have amplitude for my del of t. So this is the resultant signal. So this can be defined as phi of t multiplied by del of t is nothing but phi of 0. That is, at t is equal to 0, whatever it may be the amplitude, that is only the resulting signal. Next is shifting property of your unit impulse function. So what happens if you multiply a signal phi of t with the shifted version of impulse function? Suppose say the impulse function is shifted t naught times. That is what happens, see here. So as I have already explained this time shift property in my previous videos, I am just explaining briefly. So del of t means centered around at t is equal to 0. Del of t minus t naught means you have to equate this t minus t naught to 0 such that you will get your center point, that is t is equal to t naught. So the signal is now at t naught. It is shifted to t naught. So this is my del of t minus t naught. So if you multiply this base signal phi of t with del of t minus t naught, let us see what is the resultant signal. So I am taking this phi of t here, some signal, random signal I am drawing. So this I am going to multiply with phi of t minus t naught, that is here, right? So this is del of t minus t naught. Then what happens if I multiply the amplitude at every point of phi of t, at every point of del of t minus t naught, here it is 0. So till t naught, this will get cancelled. No signal will come. The resultant signal is 0 till t naught, right? Then what happens at t naught? This is unit pulse. So whatever it may be the amplitude, suppose say the amplitude here be x. So x into 1 will be x here, right? So again after t naught, as this signal del of t minus t naught is 0. So the base signal is multiplied with the amplitude 0. So this also will get 0. So again the signal is 0. So this will be your resultant signal if you multiply phi of t with del of t minus t naught. So this is represented as phi of t naught, right? Because you are just getting only this impulse. So this signal is nothing but a series of impulses. As I am multiplying with this one with the impulse function, I'll get only the function, whatever it may be present here, whatever the amplitude that is present at t naught, that only we are getting. So this can be represented as phi of t naught. The next signal is ramp signal. Ramp signal is indicated with r of t, where r of t is equal to t for t greater than or equal to 0 and r of t is equal to 0 for t less than 0. Suppose take t is equal to 0. As r of t is equal to t, that is nothing but whatever the value you are taking for t, that the same value will reflect as r of t amplitude. So if t is equal to 0, amplitude of the signal is 0. If t is equal to 1, amplitude of ramp signal is 1. If t is equal to 2, r of t value is 2. If you take negative values, t is equal to minus 1, t is equal to minus 2, the amplitude of r of t is equal to 0 because the signal is defined for r of t is equal to 0 for t less than 0. So if you mark all these points on the graph sheet, taking x-axis as time scale and y-axis as r of t. Now if t is equal to 0, r of t amplitude is 0, t is equal to 1, r of t is 1, t is equal to 2, r of t is equal to 2. Then for negative values of time, you take all zeros. Now combine or join all the points to get r of t graph here. So this is your r of t. Another concept involved here is, as I've explained, u of t's unit step signal is defined as 1 for t greater than or equal to 0 and is equal to 0 for t less than 0. So it looks like this. This is u of t, right? So this signal is discontinued at t is equal to 0. That is, till t is equal to 0, it is 0. Then immediately it has taken a step to 1 when t is t plus. That is immediately after 0. Now, if you integrate it u of t from minus infinity to infinity, we'll see what happens. As it is discontinued at t is equal to 0, I am taking minus infinity to 0 one integral and 0 to infinity as another integral. So what is the value of u of t from minus infinity to 0? It is 0. So 0 dt. Then 0 to infinity, the value of u of t is 1. So 1 dt. So integral of 0 is 0 plus integral of 1 dt is t. So integral minus infinity to infinity, u of t is nothing but t, that is nothing but here r of t. So integral of u of t is also defined as r of t. And this ramp signal is mostly used in checking of your PCB boards. The next signal here is exponential signal. Exponential signal is defined as x of t is equal to c into e power at. So there are two types of exponential signals here. One is exponentially growing signal shown here and exponentially decaying signal. So exponentially growing signal means it starts from 0 and increases gradually along with time. Decaying exponential signal is the signal where it starts with some particular value and as the time increases, the exponential signal slowly decreases and falls down to 0. We'll see these categories here. Suppose say if t is equal to 0, what happens to the signal? X of t is equal to c into e power a. In place of t I am writing 0. Then e power 0 is 1. So it is nothing but c. So whatever it may be the value of a here, the value of your x of t when t is equal to 0 is c, some real constant. So that is what we have marked here on these two graph sheets. Now, suppose if a is greater than 0, take a is equal to 1 in first case, then x of t value will be c into e power at, that is t. Suppose take a is equal to 2 in the second case. X of t will be c into e power 2t. Right. So the basic value is c, that is multiplied by e power t, that is multiplied by e power 2t. So the value of x of t is keep on increasing. So here if t is equal to 1, c multiplied by something, then t is equal to 2, c multiplied by e power 2t, t is equal to 3, c multiplied by e power 3t. So like this the graph is increasing. So that's why this we call it as exponentially increasing or growing graph. Next, if a is less than 0, take a is equal to 1, then x of t becomes c into e power minus t. Then if a is equal to 2, x of t becomes c into e power minus 2t. Right. So from t is equal to 0, that is the value of c, it gradually decreases and reaches to 0 at some point of time. So this we call it as exponentially decaying curve. So these exponential signals are used to calculate the growth rate or decay rate of particular signals. The next signal is sinusoidal signal. Mathematically, the sinusoidal signal is represented as x of t is equal to a cos of omega t plus phi, where here a is amplitude of the signal, omega is angular frequency measured in radians per second, and phi is the phase angle measured in radians. So if you observe, this is the sinusoidal signal with a time period of t naught, right? With a time period of t naught. So the time period t or t naught is defined as 2 pi by omega. That is, after this interval of time, again the same signal is repeated. Such type of signals we call it as periodic signals. So a sinusoidal signal is a periodic signal with a time period of 2 pi by omega. So let us check whether this continuous time sinusoidal signal is always periodic or not. So what is the condition for periodicity? Periodicity property, x of t plus t should be equal to again x of t. Let us check. What is our x of t here? A cos of omega t plus phi. Let us write x of t plus capital T. That is, wherever t is there, I am replacing it with t plus capital T. So this will become omega. In place of t, I am writing t plus capital T plus phi. Then a cos of, I am just multiplying omega t plus omega capital T plus phi. So from here, what is omega capital T? If you cross multiply this, omega capital T is nothing but 2 pi. So you will get it as a cos of 2 pi plus omega t plus phi. I'll just consider this omega t plus phi as theta. What is this now? Cos of 2 pi plus theta form, which is nothing but cos theta again. Right? So here theta is omega t plus phi. So this can be written as a cos of omega t plus phi, a cos theta, no? So that is nothing but a cos of omega t plus phi. So which is nothing but your x of t signal again. So we can say a continuous time sinusoidal signal is always periodic with a period of 2 pi by omega. Next signal here is exponentially damped sinusoidal signal. So if we multiply an exponentially decaying curve with the sinusoidal signal, the resultant is exponentially damped sinusoidal signal. As we know, the sinusoidal signal is represented as a sine of omega t plus phi, and exponentially decaying signal is represented with e power minus at. So the multiplication of these two signals will result in e power minus at a sine of omega t plus phi. Right. So if you multiply these two signals, the resulting signal is your exponentially damped sinusoidal signal. Here a should be greater than 0. Then only it will be an exponentially decaying signal. So as the time t increases, the amplitude of the sinusoidal oscillation decreases and exponentially, and it approaches to 0, the amplitude will become 0 as t tends to infinity. So this is all about exponentially decaying sinusoidal signal. Pulse signals. These are the last category in continuous time basic signals. You are given with two pulse signals, rectangular pulse and triangular pulse. The rectangular pulse signal is defined like this. Rect of t is equal to 1 for mod t less than 0.5 and is equal to 0 elsewhere. That is, the signal is extended from minus 0.5 to 0.5. Other than that, you have 0. That is, after 0.5 and before minus 0.5, the amplitude of the signal is 0 here. And as you are defining the pulses for unit amplitudes, we are taking the rectangular pulse also with the amplitude of 1. So the height of the signal is here 1, width is also equal to 1, and as you know, area is nothing but height into width. Again, it is 1 here. Coming to triangular pulse, it is defined as triangular of t is equal to 1 minus mod t for t mod t less than or equal to 1 and is equal to 0 elsewhere. So what is this? Suppose say the signal is extended only from minus 1 to 1. So right, these are the limits they have given. So in those limits, the signal property is 1 minus mod t. That is, if you take t is equal to minus 1, then 1 minus mod t means what? It will become, as you have mod, then it will become plus 1. So 1 minus 1 is 0. So at t is equal to 1, the amplitude of triangular signal is 0. Suppose you take t is equal to plus 1. Then what happens? At t is equal to minus 1, the triangular pulse amplitude is 0. Now I am taking for t is equal to 1. Then what happens? 1 minus mod t is again 1. So that is nothing but 0. Now if you take t is equal to 0, let us check what happens to the amplitude of triangular pulse. So that is nothing but 1 minus, in place of t keep 0. So that is 1. So just mark the points. At minus 1 I have amplitude 0. At plus 1 I have amplitude 0. And at 1 and at 0 the amplitude is 1. So join all the points, that gives you triangular curve. Now if you observe, these two signals are exhibiting even symmetry. That means both the signals are symmetric around your y-axis. Right? So these two signals are even symmetry signals.
For more videos, please do like, share, subscribe to our channel. Let us know your suggestions and queries in the comment box. Thank you.